The universe has always been a place of secrets, a vast canvas of shadow and light that hums with mysteries we've only begun to unravel. Imagine staring into the heart of a black hole, a place where time bends, where light itself surrenders, and expecting nothing but silence, only to see something impossible burst forth. A flare, rhythmic and alive, pulsing like a heartbeat from the edge of oblivion. This isn't science fiction. This is what the James Webb Space Telescope, humanity's most powerful eye in the cosmos, just captured. A signal, a whisper, a puzzle that defies everything we thought we knew about black holes. Something came out of one, and it's rewriting the story of the universe. Picture yourself standing at the edge of this discovery, heart racing, as the stars themselves seem to lean in closer, urging you to listen. What could it mean? Is it physics bending under the weight of a new truth? Or is it something more? A message from the void, waiting for us to answer. The James Webb Space Telescope didn't just stumble upon this cosmic anomaly. It was built for moments like this, engineered to pierce the veil of the universe's deepest secrets. Launched into the frigid darkness of space, it sits a million miles from Earth, where the air is still and the stars burn clear. Its golden mirrors, vast and gleaming, drink in infrared light, seeing through clouds of dust and gas that hide the universe's most elusive events. Unlike its predecessor, Hubble, which painted the cosmos in vivid colors, Webb sees the invisible, heat, motion, the faint glow of things long gone. When it turned its gaze to a black hole, a monster at the heart of our Milky Way, known as Sagittarius, a star, it wasn't just looking for beauty, it was hunting for truth. And what it found was a flare of light, not spiraling into the black hole's grasp, but bursting outward, rhythmic and precise, like a signal carved into the fabric of space itself. This wasn't a random flicker, not the chaotic sputter of dying stars or tumbling debris. It was structured, deliberate, a pattern that pulsed with eerie consistency, as if the black hole was speaking. To grasp the weight of this moment, you have to understand what a black hole is. A cosmic abyss so dense, so heavy, that it warps the very fabric of reality. Picture a star, once massive and radiant, collapsing under its own weight until it's crushed into a single point, a singularity, where the laws of physics as we know them cease to exist. Around it lies the event horizon, the invisible line beyond which nothing escapes, not even light. For decades, we've seen black holes as one-way doors, devouring everything in their path. Einstein's equations in 1916 gave us the math to imagine them. But it wasn't until the 1960s, with the discovery of Cygnus X1, a star locked in a deadly dance with an unseen partner, that we knew they were real. We've watched stars whip around the Milky Way's center, their orbits screaming the presence of an invisible giant. We've felt space-time ripple collisions, waves that carry the echoes of creation itself. Black holes aren't just objects. They're the universe's ultimate test, where gravity, time, and reality collide. So when Webb saw something emerge from one, it wasn't just a surprise. It was a rebellion against everything we thought was true. This flare, this impossible burst of light, wasn't a one-off. It repeated, pulsing in a rhythm that felt almost choreographed, like a cosmic metronome ticking in the void. Scientists watched, breathless, as Webb's instruments, its mid-infrared imager and spectrometer, caught the same signal across multiple wavelengths. They checked and rechecked, ruling out glitches, recalibrating systems, their hearts pounding as the data held firm. This was real. The light wasn't chaotic, like the jets of plasma that sometimes erupt from a black hole's edges. It was orderly, symmetrical, each pulse echoing the last with a precision that felt uncanny. One researcher, staring at the data, whispered, "This isn't noise. Something's shaping it." The signal wasn't just light, it was information, structured in a way that no known natural process could explain. It was as if the black hole, long thought to be a silent devourer, had turned to face us, offering a glimpse of something beyond. What makes this discovery so haunting isn't just that something escaped a black hole's grip, it's how it escaped. The pulses were brief, lasting mere seconds, but they repeated with a rhythm that felt intentional, like a code etched into the darkness. Imagine standing in a quiet room, hearing a faint knock on the wall, steady and deliberate, and realizing it's coming from a place you thought was empty. That's what this feels like. The flare wasn't the random sputter of magnetic fields snapping or debris colliding. It wasn't the chaotic roar of a jet blasting into space. It was too neat, too precise, too alive. Scientists have seen flares before, bursts of energy from the swirling disks of gas and dust that feed black holes. But those are messy, unpredictable. This was different. It was as if the universe had paused, taken a breath, and sent us a signal we weren't ready to hear. Could it be a natural phenomenon we've never seen before? Or is it something stranger, something that dares us to ask if we're alone in the cosmos? The mystery deepens when you consider where this happened. Sagittarius A star, the supermassive black hole at the heart of our galaxy, 4 million times the mass of our sun. It's a titan that anchors the Milky Way, pulling stars and gas into its orbit like a conductor leading a symphony. Webb's infrared eyes were perfectly suited to peer through the galactic dust that hides it, capturing not just a snapshot, but a living, breathing moment. The telescope's instruments track temperature spikes, velocity shifts, and spectral signatures, painting a picture of matter moving in ways it shouldn't. This wasn't just a flare, it was a performance, a dance of light and energy that seemed to defy the black hole's very nature. As the data poured in, scientists felt the weight of history shifting. This wasn't just a discovery, it was a challenge, a call to rethink everything we know about the universe's most enigmatic objects. What could cause a black hole, a cosmic vacuum cleaner, to give something back? And why does it feel like it's trying to tell us something? The pulse from the black hole wasn't just a fleeting spark in the cosmic night. It was a rhythm, a cadence, a whisper that seemed to hum with purpose. Imagine standing on the shore of an endless ocean, watching waves crash in perfect time, each one carrying a message you can't yet read. That's what the James Webb Space Telescope captured, a series of infrared flares bursting from the edge of Sagittarius, a star, the supermassive black hole at our galaxy's heart. These weren't the wild, chaotic eruptions scientists expected from the turbulent disks of gas and dust spiraling into oblivion. They were precise, repeating, like a drumbeat echoing across the void. Each pulse lasted mere seconds, vanishing only to reappear, as if the black hole was breathing, exhaling light in a pattern too orderly to be chance. Scientists stared at their screens, hearts pounding, as the data painted a picture of something impossible. A signal that felt alive, orchestrated, as if the universe itself was tapping out a code. This wasn't just a flare. It was a mystery that tugged at the edges of everything we believe about reality. What makes this pulse so haunting is its defiance of everything we know about black holes. These cosmic giants don't give, they take. They're gravity's ultimate trap, swallowing stars, gas, even light itself, leaving nothing but silence in their wake. Yet here was Webb, its golden mirrors trained on the Milky Way's core, catching something breaking free. The flares weren't random flickers of energy, like the magnetic storms that sometimes flare from a black hole's accretion disk. They were structured, symmetrical, each burst mirroring the last with a precision that felt unnatural. Scientists ran the numbers, cross-checked instruments, and held their breath as the data held firm. This was no glitch. The pulses carried a signature, energy levels that stayed consistent, timing that followed a rhythm, like a heartbeat in the dark. One astrophysicist, her voice trembling with awe, said, "It's like the black hole is singing." But what could create such a song? Was it a quirk of physics we've never seen? Or something stranger? A sign of something deliberate? Something intentional? To understand the weight of this moment, picture the chaos of a black hole's edge. The accretion disk, a swirling maelstrom of superheated gas and dust, spins at unimaginable speeds, caught in the black hole's relentless pull. Sometimes magnetic fields twist and snap, releasing bursts of energy that flare briefly before fading. These are the tantrums of a cosmic beast, wild and unpredictable. But what Webb saw was different. The pulses didn't flicker and fade like typical flares. They repeated twice in quick succession, then fell silent, only to start again. The timing was exact, the energy levels steady, as if something was controlling the flow. It wasn't the messy sputter of plasma or the violent roar of a jet shooting into space. It was too clean, too precise, like a signal you'd expect from a machine, not a monster. Scientists scoured their models, searching for a natural explanation, magnetic reconnection perhaps, or a clump of matter torn apart at the event horizon, but nothing fit. The pulses were too orderly, too purposeful, as if the black hole was doing something on purpose. This discovery didn't just challenge our understanding of black holes. It pushed us to the edge of physics itself. For decades, we've struggled to marry Einstein's theory of gravity with the strange, subatomic world of quantum mechanics. Black holes are where these two realms collide, where gravity warps space-time so fiercely that our equations start to fray. Near the event horizon, where light teeters on the brink of capture, things get even weirder. Some theorists suggest that quantum effects might ripple outward, subtle echoes of particles dancing at the edge of reality. Could Webb's pulses be a glimpse of this dance, a sign of quantum gravity at work? The infrared data showed thermal spikes and velocity shifts, hints of matter moving in ways that defy our models. One researcher, poring over the spectral signatures, mused, "This could be where relativity and quantum mechanics finally shake hands." But the symmetry, the rhythm, it felt too perfect, too choreographed, as if something was shaping the chaos into a message we're only beginning to hear. The idea of a message, of course, pulls us into dangerous territory. It's easy to let imagination run wild, to see patterns and call them signals. But the pulses were so precise, so unlike anything we've seen, that even the most skeptical scientists felt a shiver of curiosity. Could this be a natural phenomenon we've never encountered? A new kind of ejection from the black hole's edge? Or is it something more, a hint of something beyond nature? The data didn't scream alien, but it whispered it, softly, insistently. Some researchers compared the pulses to the rhythmic signals we send into space, hoping to catch the ear of a distant civilization. Others cautioned restraint, pointing out that no known process, natural or otherwise, fully explains what Webb saw. "We're seeing choreography, not chaos," one scientist said, her words echoing through conference halls buzzing with debate. The pulses were a puzzle, a cosmic riddle that demanded we look closer, listen harder, and dare to ask questions we've long avoided. As the scientific community grappled with the data, a quiet excitement began to build. This wasn't just a discovery, it was a call to action, a challenge to rethink the universe. Observatories around the world turned their eyes to Sagittarius A star, hoping to catch another pulse, another clue. Teams pored over Webb's data, comparing it to X-ray and radio observations, searching for echoes of the same rhythm. The pulses had appeared in infrared, but would they show up in other wavelengths? Could they be the key to unlocking a new chapter in physics, or something even more profound? For now, the black hole kept its secrets, but Webb had given us a glimpse of something extraordinary, a crack in the cosmic wall, letting light and mystery spill through. As we stand on the brink of this enigma, one thing is clear. The universe is speaking, and we're only beginning to understand its language. What comes next could change everything. The universe has a way of humbling us, of reminding us how small our understanding is against its infinite expanse. The pulses from Sagittarius, a star captured by the James Webb Space Telescope, weren't just a scientific anomaly. They were a cosmic wake-up call, a signal that something profound is happening at the edge of a black hole. As scientists leaned into this mystery, their excitement was tempered by awe and a quiet unease. What if these rhythmic flares, so precise and deliberate, were more than a quirk of physics? What if they were a glimpse of something, or someone reaching out from the void? The idea feels like a leap, a whisper of hope or fear that tugs at the edges of our imagination. Yet the data is undeniable. These pulses don't fit any model we have. They're too structured, too purposeful, like a lighthouse beam sweeping through the dark, calling us to look closer. As we stand on this precipice, the question isn't just what these pulses are, it's what they mean for our place in the cosmos. The scientific community didn't just sit back and marvel, they sprang into action. A global chorus of minds united by curiosity. Within hours of Webb's discovery, observatories from Chile to Australia turned their eyes to the Milky Way's heart, their telescopes humming with purpose. Radio arrays, X-ray telescopes like Chandra, and even ground-based optical scopes joined the hunt, each searching for echoes of the same strange rhythm. NASA redirected Webb's schedule, granting extra time to stare at Sagittarius A, its instruments now tuned to catch every flicker, every pulse. Engineers upgraded its infrared filters, shaving seconds down to milliseconds, ensuring no moment of this cosmic dance would slip away. They built real-time alert systems, so if another flare erupted, telescopes across the globe would swivel in unison, capturing it in every wavelength possible. This wasn't just observation, it was a mission, a race to pin down the truth before the black hole fell silent again. The air crackled with anticipation, as if the universe itself was watching, waiting to see what we'd do next. But what could these pulses be? The natural explanations, magnetic storms, plasma jets, or debris collisions, felt like pieces of a puzzle that didn't quite fit. Magnetic reconnection, the snapping of twisted field lines, can spark flares, but they're chaotic, messy, not the metronome-like rhythm Webb recorded. Jets, those violent streams of matter blasting from a black hole's poles, are too sporadic, too broad to match the precise, seconds-long bursts. Scientists even considered a star grazing the black hole's edge, torn apart by gravity's pull, but the energy signatures didn't align. The pulses were too clean, too consistent, like a signal engineered to stand out. This pushed researchers to the fringes of physics, to ideas once confined to theory's wild edges. Could these flares be a sign of quantum gravity, where the subatomic world dances with spacetime's fabric? Or might they hint at something even stranger, a wormhole, a tunnel through the universe, leaking light and matter from another place or time? The idea of a white hole, a theoretical opposite that spits out what black holes consume, began to surface in hushed conversations. If true, it would turn our understanding of black holes upside down, making them not just devourers, but gateways. The possibility of a wormhole or white hole isn't just a thought experiment, it's a challenge to everything we know. Einstein's equations allow for such cosmic shortcuts, bridges through space-time, that could connect distant realms or even other universes. A rotating black hole, spinning at unimaginable speeds, might twist space-time so tightly that it opens a fleeting path, letting something slip through. Webb's pulses, with their eerie timing and structured bursts, could be the first glimpse of such a phenomenon. Imagine matter or light spilling out from a hidden corner of the cosmos, carried through a tunnel we can't yet see. The infrared data showed hints of this. Velocity shifts, thermal spikes, as if something was being ejected, not just flung. One theorist, staring at the numbers, said, "It's like the black hole is leaking and we're catching the drips." But leaks imply a source, a place beyond the event horizon. If these pulses are coming from a wormhole, they could be the first evidence of a universe interconnected in ways we've only dreamed of. And if they're from a white hole, we're witnessing the birth of something new, a cosmic act of creation. Then there's the idea that dares us to dream bigger. What if these pulses aren't natural at all? The word alien feels like a spark in a dry forest, dangerous and thrilling. No one's shouting it from the rooftops, but the whispers are there, in the margins of academic papers and late-night debates. The pulse's rhythm, their precision, feels eerily like a signal we might send, a beacon, a code, a message. Scientists compared them to our own radio broadcasts, the ones we flung into space hoping someone's listening. There's no decoded message, no clear sign of intent, but the similarity is uncanny. Some even floated the idea of astroengineering, a structure, a probe, or a machine orbiting the black hole, harnessing its immense energy. A Dyson sphere around a star is one thing, but a civilization tapping a black hole's spin, That's the stuff of cosmic ambition. Critics are quick to caution, we've seen no proof, no undeniable mark of intelligence. Yet the pulse's structure begs us to stay open, to wonder if we're hearing a whisper from a mind not our own. Whatever the truth, this discovery has set the scientific world ablaze. Papers flooded journals, each one wrestling with the pulse's meaning. SETI teams quietly logged the waveform, adding it to their databases of cosmic anomalies. Conferences buzzed with debates, some calling it a new kind of physics, others daring to mention white holes or alien constructs. The speed of it all was dizzying. Science usually moves at a crawl, but this was a sprint, a global effort to chase a mystery unfolding in real time. Webb's data became a rallying cry, a reminder that the universe still holds secrets that can unite us in wonder. Whether these pulses are a natural phenomenon, a quantum quirk, or something far stranger, they've cracked open a door to the unknown. Black holes, once thought to be the end, might be gateways to new physics, new realms, or even new minds. As we keep watching, listening, and dreaming, one thing is certain. The universe has spoken, and we're on the cusp of answering. What do you think it's trying to tell us?